Hey everyone, welcome back. I'm glad you're here. Today's video is on this amazing little power hammer. I first saw this design from my friend Dave Hammer about 3 years ago, and I was immediately excited to build one for our shop. And we did that. And today's video is on how we built this hammer. I'm not going to go into the specifics of the air system because he has plans for that, which are in the link down below this video. But this machine is really crazy. Kind of fun to see this 15-pound power hammer next to the 2B, which has a 165-pound RAM, next to the steam hammer, which has an 800-pound RAM. Speaking of the steam hammer, we have our new merch up on our website. This is a sweatshirt featuring that 800-pound Niles Bement steam hammer. And there's also a link below in this video for this sweatshirt and t-shirts as well. But anyhow, I'm glad you're here for the video on how we built this 15-pound air hammer. Let's go.
Now, I'll start by saying that one of the things that pushed this project over the edge and made it finally come to life was the fact that a good friend gave me a bunch of steel that was dug up from a old foundry or furnace up in Delaware. And all this steel was buried and needed sanded to get the rust and the dirt off of it. But I took the angle grinder and sanded it all clean so that we would have nice prep for our welds. Once that was done, then I was able to take these pieces and stand them up and begin to mock up the hammer. The round piece is the anvil. That large piece that I'm standing up there is the spine of the hammer, as well as the base plate, which you can see. But before we actually cut any steel, I went into Fusion 360, which is essentially 3D CAD, and drew this hammer up. And the thing I love about that is it gives me the ability to make mistakes on paper, quote unquote, before we actually cut any steel. Here you can see the final plans all drawn up, ready to cut. And so took those plans. Now, they mirror so well with a tool here that you see me using called the saw gear. It essentially is a CNC back gauge, and I can set that back gauge and then bump the metal into it, and it will be exactly what the measurement is that we typed in. It's an amazing tool. So here I'm cutting the RAM, which you can see, and all the parts were cut on our large Cozen saw. Once all the parts were cut, then I took the RAM, and you can see me cleaning it up here on the belt grinder. Now this will slide inside of a guide housing that also incorporates some high density plastic as a bearing surface for the guide, but that entire RAM needed cleaned up so that it slides freely and smoothly within that guide. And this belt grinder that you see us using is an old Broadbeck that I bought off of a friend. But spoiler alert, we just got a new belt grinder that I'm really excited to show. And I'm going to be using that in an upcoming video to finish an old tool from a long time ago. Now I'm still working on the RAM, and this is a technique that I use. It's an old school machinist technique to blue the piece, and I need to mark the center, so I'm going to take the outside measurement, divide it in half, set these dial calipers, and these are a cheap pair, so I'm going to use the edge of the dial caliper to scribe the bar, and that'll help me find the center. Once those scribe marks are made, then I'll take a center punch and punch that to drill the hole. Now, you saw me moving the mill to set it up, and we actually had to do a special setup here because the mill wasn't tall enough to hold this piece in the vise. I had to clamp it to the bed of the mill in order to drill this hole in the end. I am currently on the hunt for a larger mill with a much longer bed. Because of the architectural work that we do, we need a much larger mill. But this Bridgeport's been great up till now. So once that hole is drilled, while it's still held in the mill and I can work on it and keep everything straight, we also tapped that hole. So this was a fine thread. This was a 1/2 inch 20 thread that we drilled and tapped into the end of the RAM. And a happy shop is a clean shop. So put everything away when you're done.
Okay, so I've been busy all afternoon. I'll probably do a lot of voiceover on this video, but I wanted to explain what I was doing with drilling and tapping that hole in the top of what will be the RAM. So that hole is designed to basically receive the piston which is that air cylinder. But we have this alignment coupler, and what this does is it takes out any misalignment from either the layout on the machine or the hole not being tapped perfectly. But we're going to thread this in, check it out, and hook up the air cylinder as well.
I have to say, even the small steps like this one are so rewarding because you've planned something for so long, seen it on paper, thought about it, just, considered all the details. It's so much fun to see it finally coming together. And since all the parts are cut and everything has been double checked, it was finally time to start the fabrication of the hammer and to weld these pieces to the base plate. So you can see everything is ground and down to clean bare metal so that we get really good bond on the weld. Took our time definitely with the main column to make sure that everything is super square and straight. And once it's all tacked up on all sides, then we just burn in and put on these full structural welds. And here you see Drew working at the drill press to drill holes for the actual dies. These will also get tapped to receive the bolts to bind up to the RAM. This piece is the top plate that the piston rests on. It sits on top of what Dave calls in his plans the Portico. So we needed to drill this hole to allow the piston rod to slip through, and we used an annular cutter to do this. And boy, these things are amazing. You can see how quickly this cutter just hogs out this hole, and what it does is it actually cuts a slug out of the metal. It doesn't remove all the material like a standard drill bit, but they're just phenomenal for making a hole through plate steel. This is 1/2 inch thick steel. You saw that just plug fall out of the bottom there. The air cylinder was then placed through that hole, and the holes for mounting the cylinder to the top laid out, drilled, and tapped. Now what I'm working on is the RAM guide assembly. I did fabricate this a bit differently than Dave's plans, but I'll say if you have limited fabrication experience, follow his plans to a T. He's done a great job of figuring it out and making this build accessible to someone with limited tools and limited experience in fabrication. We obviously have a very well equipped, very well laid out shop, so I did take some artistic license and do a few things a bit differently, but in the end it all worked out extremely well. So you can see Drew now tapping those holes to receive that air piston, and we are ready to do the final assembly. This is the cutting of the high density plastic for the RAM guide and fitting that inside of that guide. Dave again has a really cool way of holding that all together, which I'm not going to delve into in this video, but you can also see the holes that we drilled and tapped in that guide assembly to allow this plastic to get tightened and hold the RAM in really sweet, really critical alignment. This is not sloppy like an old mechanical power hammer, but everything is kind of precision held together, which is super attractive. And again, I have some specific tooling that I plan on making for this hammer, some very specific die setups, and having the ability to have the top and bottom dies in perfect alignment is really huge, and I really love the precision and fit up of that. Now here I am plasma cutting by hand the brackets and the braces for the Portico. These are very structural, so I plasma cut these again out of some surplus steel that my friend gave me. This is 1/2 inch thick mild steel, and just plasma cutting these out by hand. The belt grinder was essential for cleaning them up. You can see I'm using the platen to clean up the straight portions, and then that large radius portion, I'll use that larger wheel on the bottom to get in tight and clean that up. Really awesome to have this tool to do this type of work. It's just beautiful to have the proper tool to do the job. Once the profile was ground, then he used the wire wheel to buff and clean the surface of the metal. This also preps everything for painting so that every surface is clean and will receive the paint well. Here, Drew and I are aligning the RAM guide and welding that together. Now, we just got this new Everlast water-cooled TIG welder, and you'll see more about this in an upcoming video, but so far it's been a great machine, and we definitely needed a second water-cooled TIG welder as we grow and just get into more projects we have added to our tooling, which again is part of this whole hammer build. We're just really trying to improve everything we're doing in the shop, and that welder has been a fun addition. And this is where it really gets fun to see all these components that we've been working on for so long come together. You can see the RAM guide assembly and all of the parts being bolted in. The anvil was welded in, and then we went to work welding in the last piece, which was the Portico up top that held the RAM and the piston.
All right, let's do it. Let's try this guy out. Put a ton of work into it. I ran it just preliminary, but it's time to forge hot metal with it. Let's go. Yeah, baby. How fun is that? So that's 1/2 inch round, and it flattened it out in no time. So cool to see it hitting hot metal. Just for the fun of it, I'm going to try to heat it up and just forge a shoulder. See how fast it'll take down the middle section. Boy, that's cool to see hitting like that. So fun. Oh man, that is so fun to see. You just reduce that middle section down. Man, I am so excited. There are so many possibilities for stuff that you can do on smaller hammers. And that's why we made this. I realized a little while ago that we had things well covered with big hammers. I mean, we have a 2B, We have an 800-pound steam hammer. We have a Nasal 3B, which is just shy of 300 pounds. But it's really cool to have a small hammer, something you can put smaller dies into for some of the high-end architectural work that we do. Man, it's just got so many possibilities. I'm excited to get going on this thing and excited to show you guys this build video. Okay everyone, a few final thoughts as I wrap up this video. Now, this hammer is done in the sense that we can run it just like you saw, but it's not completely finished. It still will get mounted to a large wooden base that will get a treadle hooked to it, and that treadle will hook to the linkage to control the hammer. Now, you saw me doing that by hand today, literally by hand, just to test it out and have some fun with it. But the final plan is to properly fit a linkage to this, as well as hook up the single blow feature, which is probably what I'm excited about more than anything on these hammers. Again, my friend Dave Hammer, who has the plans linked below, came up with the way of making these hammers do just a single hit. And that is just phenomenal, especially for like setting tools or repoussé, things like that. I'm so excited about that ability to do a single hit with these hammers that we actually have 2 more of these hammers in the works. But instead of a 15-pound ram, both of those hammers are going to be a 35-pound ram. And they'll have a full anvil down to the floor, you know, kind of like you would imagine a full power hammer being. But anyhow, this thing was so much fun to test out and show you guys on this amazing little hammer. Again, if you wanted to build your own, you can get plans to do that. But just the ideas that this is opening up as far as different tooling. These hammer dies are not complicated to make. It's literally cut to length, drilled 2 holes, and just weld up a small bottom die. It'd be super easy to come up with custom tooling for all different jobs. But for some of the architectural work that we do, it's really nice to have smaller dies, dies that are easy to make, that aren't a huge investment of money, something that's quick and easy to tool up for a single job. That's why we made this hammer. This hammer was kind of the guinea pig to get us going into this whole thing. And that's why we're investing the time in the 2 35-pound hammers. They're gonna be exactly the same. They'll be twin hammers, 2 35-pound hammers, same dies. That way you can just you know, use both on a job, have different dies in each hammer. Just super excited about that. Thanks to all of my friends who, you know, just help out and support. My friend Denny, who, you know, got me the scrap steel that really pushed this project over the edge, because it's hard to throw time and money at extra projects like this. But when you get all the steel basically for free, that's just so awesome. And so thankful for all the great people in my life. Thankful for all of you out there supporting this channel. Do all the things, hit that like button, subscribe. Thank you for joining us, and I hope you'll be here next time as we take a look inside the shop. Who knows what craziness we'll be up to. Anyhow, so glad you're here. Thanks for joining us.